Welcome to part 4 of Competency 14. In this video, we will work with statistical inferences. Number 1, every hour a scientist counted the number of bacteria growing in a certain medium. The scientist recorded the results in a table and produced a scatter plot shown above. If P of T is the mathematical model for the number of bacteria in thousands at time t hours, which of the following expressions is the best fit for P of T? Okay, so what we're asking is, which is the best equation? Look at what we have. Look at the numbers. Look at the picture. Well, the expressions that are given, A, it's linear. That has a curve to it. It is not linear. B is quadratic. I'm not buying it. That just doesn't look quadratic to me. And if you are familiar with the properties, I'm sure that you would probably agree. It doesn't have that. I agree that it should be close, but the numbers just don't agree with what I'm seeing. And if you put it in your calculator, you would see that the numbers just don't work out. Okay? When we got to these values, okay? All right, so let's mark that out. Now, I think I may have mentioned, I think it's exponential. Now, before we get excited about that, which would be C, okay? Let's look at D. D is logarithmic, and that would look like this. So it's literally curved the wrong way. So I'm not buying D either. Okay. Now let's put C in our calculator. So let's push table. It's already in there. And enter, let's say 0 to start at 0 and then steps of 1. And let's build ourselves a table. Now, here's the thing. We don't want perfection, but we want to see a pattern that is very similar. Well, let's arrow down. I see a nice similar pattern of growth. Definitely. So I think C is definitely a great fit. But just to make some of you feel better, let's put in B and see what it looks like. Let's go back to our table, clear it out. And let's say 300. Of course, we have to use x in the squared plus 100x plus that 10. Now let's look at those numbers and see if we have an issue with them. Okay, start with 0, steps of 1. Okay, ooh, no, not even close. So my instincts were correct that it just doesn't follow that nice exponential function, that look that it should have. Okay, let's look at number 2. Okay. In 2024, there were 324,582 licensed teachers in a certain state. The ages of the teachers were modeled with a normal distribution. The mean age was 43.5 years old with a standard deviation of 8.2 years. Based on this distribution, which of the following is the best estimate of the number of licensed teachers in the state in 2024 with an age of 59.9 years old or greater? Okay, we have a standard deviation image here that we can work off of, so I can kind of explain this to you. Okay, it's not perfect, but it's good enough. Okay, so I can just show you what we're doing here. Now, the empirical rule will have to be applied here. And please note this standard deviation. So what are we going to do? Okay, we are going to take the given mean and then subtract that from our years that we're focusing on, where we need to measure. Okay. All right. So remember, this at 0 is always our mu. And in this case, our mu is 34.5. Okay. Now, 59.9 is greater than that. So we know somewhere over here, that's where our age is going to be. And that's where our concern is. All right. Okay. So let's subtract those. So second mode. Okay. So 59.9 minus the 43.5. Okay. That distance in age is 16.4. But our standard deviation, the value of it in years, suspiciously, is 8.2. So divide by 8.2. And there you go. 2 standard deviations. So that tells me that right here at 2 standard deviations is where we have our 59.9. Now let's apply the empirical rule. That empirical rule says within 1 standard deviation, we have 68.3. Within 2 standard deviations, we had 95.5%. Remember, those are percents. So, what does this tell me? That on either end of this, on either end, these two ends together, they're going to be the difference between 100 and the 95.5. And I can tell you right now that for this problem, we most likely, in fact, I know we're going to get our best number out of just using 95. We can try them both because this will not be perfect. Okay. So 100 minus 95, that gives us 5. We divide that by 2. That's 2.5% at this end. Okay. All right. Remember, we need to find out who's older. We don't care about younger. Okay. Which would be over here, this part. That's younger. That's not what we're looking at. Okay. So I'm actually going to get rid of that. We don't want that. We want the 2.5% multiplying it by this given number of teachers in the state, multiply those together, and that will actually give us the number we need. Okay. Now I'm going to clear this out and type it in 2.5, but I need that to be a percent. So second percent, then times that nice big number 3, 2, 4, 5, 2, 8, and enter. Well, that is about 8,114. That's just a little bit over 8,000 teachers. Now, remember, we had a bit of an error going on because we used 95 instead of 95.5. Okay. Well, let's do that. 100 minus 95.5. Okay. Now, divide that by 2. Okay, 2 1/4. All right, so I'm going to clear it out. And I'm going to say 2.25 second percent and multiply it by that large number again. 34582. Yes, and push enter. See, it gives us underneath. And because we're kind of estimating the difference in the numbers, look at B, C, and D. There's absolutely no way. So, and it says the best estimate, yes, A, 8,000 teachers. Okay. Right. That wasn't very tough. I drew a picture to kind of explain it to you, but really, this would be if they were going to ask you this question, this would be more in the lines of the type of question. Even on the high school cert exam, it would have been something, it's always going to be something. Well, when I say high school, for the 7 to 12, 235, you take it. This kind of question is more likely to be on the university based. On the real test, no. However, there are rather a couple questions that ask you about these properties in not such a convoluted way, okay? You still have to know them, all right? All right, let's move on. Number 3, a scatter plot shows the relationship between two sets of data, X and Y. The line of best fit of the relationship between the two data sets is shown. Based on the line of best fit, which of the following is the best estimate of the value of Y when the value of X is 14? That's not tough. And this is a very good question. Definitely expect something like this. Okay. So that means going across, our closest is 5. Probably isn't 5 in reality, but that's our best fit. Okay. Right now, what we have here before we move on is information. Okay. We dealt with the percents. Remember, we had the empirical rule. Now, this is standard distribution at 80%, 90%, 95%, 98, and 99. Very important when it comes to confidence levels, okay? Okay, so I, on the test, no, I don't remember this at all as being something that I had to memorize, okay? That's why I'm giving you the table. Now, having a question where they give you the information, remember, they change the questions up, okay? There are some field test questions, so depending on when you take it, you know what those are, but for the most part, they would embed this information in the question for you, okay? And then you would use it. Uh, Even on the high school exam, this is not going to be a issue. You don't even have to deal with the Z scores, calculating and all that stuff. And you have a TI 84. So no. But please make note of this equation here, the confidence interval expression. Okay, that we are going to use. But we'll have to use the given Z scores and the given sample size with the deviation. Now, this standard deviation is a sample deviation. That's why they use an S instead of our sigma. Okay. Right. So we're talking about sample situations, not population. So you kind of have to know about that. Why is there an S there and not a sigma? Okay. And N is our sample size. All right, so let's try to answer some questions with this. Number 4, 90 mathematics professors stated how many minutes they required to grade a student's final exam. The mean time was 18.6 minutes with a sample standard deviation of 3.5 minutes. What is the 90% confidence interval for the mean number of minutes required by all mathematics professors to grade a student's final exam? Okay, some things I need to know. First, let's pay attention to this. That's our mean. Okay, and this is our S that we needed. Okay, so we know that we have mu equals the 18.6 plus or minus. Now, we have a 99% confidence interval. That means we need our z-score, and that is 2.575. Okay, which I got off that chart. Okay, so here, I can write this better. This is off the chart, so that's not something that you're going to need to calculate. Okay, as I stated before, this is a bit beyond the scope of the middle school test. However, if they give you the information that you need, like the Z score, and then they ask you to calculate it, that is within the scope. Okay. So don't just reside yourself to, oh, I don't need to know this. Not true. Okay. So our S is our 3.5. And then we need the square root of our sample size, which is right here. That's our 90. Because they asked 90 math professors in the beginning before they started giving us all this information. Okay, so we need to put this in the calculator. 18.5. Glitch. Well, what do you put in? You can't put in positive, negative. So you got to start with one. Now, let's look at our ABCD options. Well, that would be the reason I do the negative or the subtraction first is because that's the first number. Now, there are some things that we're going to have to note. I'll talk about them as we go. So minus 2.575 parentheses, and the fraction 3.5, go down. Second radical, that's where my 90 goes. Arrow over, close parentheses. I like to close parentheses. It'll work fine if you don't. Okay, all right, so let's push enter. Okay, well, with some rounding, we have a taker 17.65. So that gets rid of A and gets rid of D. Well, I'm going to go with B, and I'll tell you why. C is not valid. The definition of confidence interval is that somewhere between a minimum and a maximum value lies our mean of our sample. We are saying that we're very sure that we're correct within 99%. It will be in there somewhere. It won't be less or greater, okay? And that's a pretty good confidence interval. All right, so the fact that C is written incorrectly, that just gets rid of that. It just doesn't go with the property. All right, so let's see here. Number 5, let's go up a bit. The noise level for hospitals is a normal distribution for which the standard deviation is accepted as 4.5 decibels. Okay. All right. So that is a level of acceptance. All right. A hospital, I'm sorry, a health card official is tasked with creating a 90% confidence level for the noise for all hospitals. He uses a sample of 20 hospitals whose mean noise level is 52 decibels. What is the 90% confidence interval for the mean noise level in decibels for all hospitals? Okay, we'll use the same expression. Okay, so let's clear this out. I'm going to go ahead and just type it in. Okay, so we're given a mean of 52. Now I am going to subtract first. Okay. All right. Now from our table with 90, we have 1 point, our z-score that is, 645. Okay. Now our parentheses, then our fraction, our S is 4.5, and then we need second radical. And how many hospitals did it say? It said 20 hospitals. Okay, so we have 20 here, and then we arrow over. close our parentheses, and enter. Okay, now that would be our smallest number, and that is 50.34. Well, looks like it's been rounded up a bit more. So I'm going to say A and B are pretty good. Okay. All right. But I don't believe at all. In fact, I know for a fact that B and C will not work. So now we have to check, okay, which we didn't do in the prior question. Okay. And you could check that if you want. So what do we do to check for the larger value? Well, I can see from A and D already that there is something really wrong. I'm looking at the numbers being the same. You don't need to check that value. This is incorrect. It doesn't make sense. 53 can't be less than 50. So A is simply written incorrectly. That's just something that you're going to have to recognize and check for. But let's go up, capture what we have. Okay. Now I like to do the little trick of up and down. So it will get me to the first of my expression. And then I arrow over, type over plus. Okay. See what it did? Now enter. And that does give me a rounded amount that's correct. And D would be the correct option. Okay. All right. Just be careful on those symbols. Make sure that they go the correct way. I've actually had some tests thrown in that I've had that happen. You, it's just something you have to check first, okay? All right, so let's look at number 6. A survey of 60 homes in Austin discovered that the average age of their homes was 24 years with a sample standard deviation of 4 years. What is the 90% confidence interval for the age of the homes in Austin? Okay, well, we need 25 first, all right? So 25, I'm going to go with minus. Now, our z-score from our table is 1.96. All right, there's my parentheses and my fraction. My s is going to be my 4 here, 4. And then second radical 20, let's see, yeah, that's the average age. No, 60 homes. Sorry, I was looking at the wrong thing. 60 homes, arrow over, and of course, I close my parentheses. So our first value is 23 point, close to 24, 23.99. That's what it rounds to pretty nicely. Okay, well, that gets rid of B and D. Now let's look at our symbols. Okay, I do not like A again, but we need to check the larger number. Go up, capture, then go up and down. That's just a nice little trick I learned. It just gets me closer to the front. And then type over my plus and enter. And yes, that actually works nicely. Okay, this is the last question in this video. Once again, you guys are amazing. Thank you for watching, liking, sharing, and subscribing. It's really helping us. And also for those of you who have visited the website, thank you very much. As time goes by, please remember our website and look for other things being posted. You never know, they might help you out in the future. Happy testing, everybody.